Okay, in this video we're going to look at this practice quiz on hyperbolas that's got two main problems on it. So for the first one, we're given an equation in expanded form, and we're asked to write it in standard form and come up with some of the components characteristics of it. So let's start by taking that equation, and we need to put it into standard form, into our form that we can work with. So to do that, we're going to need to get our x's and y's on the same side of the equation, and then maybe complete the square. So I've got x's on the right, y's on the left. So I'm gonna add this x squared. I'm gonna subtract this 18x. I'm also gonna take this 19 and I'm gonna add it to both sides, so that I get that 19 on the right and my x's on the left. So I should have x squared, take away 18x, and then I'm going to group those together because we're going to complete that square in just a minute. And then we've got our y squared term that's got a negative in front of it. So I'm going to go ahead and factor out that negative. From both the y squared and the 12y term. So I'm going to have minus 12y. Right, and on my right side, I added that 19 to both sides, so I've got just a 19 on the right side. Okay, so now we need to complete the squares of both the x and the y terms. So for our x squared, we're going to take half of negative 18, square it. Okay, so that's 81. Don't forget to add 81 to both sides of that equation. And for our y squared, we're going to take half of that linear coefficient and square it. And we're going to add that to the right side. But be careful, because we actually added a negative 36. So we need to make sure that we are adding a negative 36 to both sides and not a positive 36. Be mindful of that coefficient that's outside of the parentheses there. Okay, so what do we end up with? On the left, now we've got the binomial x minus 9 squared minus y minus 6 squared. And then on the right, 19 and 81 is 100. Take away 36, leaves us with 64. Okay, so we're almost in standard form, but the right side has to be equal to 1. So if we take that 64, divide by 64 to make 1, and divide each of our terms on the left by 64, then we'll be good to go. So 64 over 64 is 1. I'm just going to replace that for time's sake. Okay, and now we're in standard form. So let's take that equation and write it in our answer blank. Okay, so we got x minus 9 squared over 64 minus y minus 6 squared over 64. And both our hyperbolas and ellipses should be equal to 1 on the right side. Alright, and then that should say hyperbolas. Alright, so we also want to find the asymptotes, lengths of our axes, and the eccentricity. For that, I need to graph it. So what if we go to our graph? We can go ahead and pull out some things from our equation. We can pull out the center, which is going to be at 9, 6. Let's see, we can go ahead and find our A, B, and C values. Okay, our A values is we get from our A squared underneath our X. So if A squared is 64, A is 8. B squared is 64 underneath the Y, then B is 8. So now if we wanted to find C, which we're going to need for our eccentricity, then we can use the Pythagorean theorem. So we have A squared plus B squared equals C squared. Okay, so 64 and 64, that makes 128. Okay, so we want to get just c, square root both sides of that. So c is the square root of 128, which if we factor out a 64 from that, so that's root 64 times root 2, that's going to be 8 root 2 for our c value. Okay. Let's see, since we're here, why don't we go ahead and fill out these last 3 blanks, since we have all we need for that. The transverse axis is 2a, so 2 times 8 is 16. The conjugate axis is 2b, so 2 times 8 is also 16. And our eccentricity, which is e, is the ratio of c to a. So c is 8 root 2, a is 8. So if we have 8 over 8, that makes 1, so 1 times root 2, we just have root 2. And that makes sense, our eccentricity should be bigger than 1 for a hyperbola. Alright, so now how are we going to find these equations? If you memorize the asymptotes, if you memorize the equations for those, then you can plug those into that weird point slope form. But I need to graph it. So I'm going to go to graph, and let's see, what points are we looking at? We've got 9, 6, and we need to go out 8 in each direction. So my scale for the number of tick marks I have, I believe is going to need to be by 2s. Alright, so our center was at 9, 6. So if we plot that point, over 9, up 6. And our a value was 8, so I need to go out to the left and right 8, since that's under the x term. So that would be a point here. 9 plus 8 is 17. So we're going to have a point right here. Okay, so that's our transverse axis. For our conjugate axis, we need to go up 8 and down 8. So if we go down 8 and up 8, 2, 4, 6, 8. Okay, so that kind of gives us the midpoints of a rectangle that we're going to need to create. So if we box those in, then the diagonals of this box are going to tell us where our asymptotes are going to be. So let's go ahead and sketch those. Okay, we know that the center is at 9, 6. So we automatically know a point that's contained on each of our asymptotes. And we know we can find our slope, which for this line here is going to be 1 over 1. Since our a and b values were both the same, then we could just do b over a, 8 over 8, which is just 1. So we're going to have y equals 1x. And then to find that y-intercept, we can plug in our point 9, 6. Okay, it's got an x and a y value in it. So plug in the y value, plug in the x value, and solve for b. So subtract 9 from both sides. Our b value is negative 3. So our first asymptote is y equals x minus 3. Go ahead and fill that into our answer blank. Right, to find our other one, our slope is going to be the opposite of that one. Okay, so it's going to be y equals negative x plus b. And again, that line contains the same point as the other one, 9, 6. They both intersect at that center point. Alright, so plug that in. We have 6 equals opposite of 9 plus b. Add 9 to both sides, b is 15. So our equation for that one, y equals negative x plus 15. Alright, we can plug that into our blank. Alright, and that takes care of number one. We found our standard form equation and each of the components that we were asked for. Let's look at number two. Okay, number two says write the standard form equation of the hyperbola whose vertices are 3, 0, and 3, negative 18. And that gives us our focus points. Okay, right away I need a graph for this one. So we can go ahead and graph our vertices and our focus points. It looks like we need to go down to negative 18, so I'm going to again make my scale by 2s. You can just barely get it on there. Alright, so our vertex points are 3, 0, and 3, negative 18. Alright, so here's 3, 0, 3, negative 18. Okay, so what else do we have? We have focus points. 3, comma, negative 9 plus root 145. Root 145 is going to be a little bit bigger than 12. So we're looking at points telling us that this guy is going to be our C value, because this kind of gives away our center right here. If we look at our graph, halfway between these 2 points is going to be 3, negative 9, which is where our center has to be. Okay, so if we're looking for the standard form equation of the parabola, just from those 3 points we have on our graph, we know that it's got to open up and down, since those are our vertices. They're vertical from each other. So that tells us that our y is going to be our first term, and our x is going to be our second term. Okay, we just need to find our a and b values and our h and k values. Well, we just found our h and k values as 3, negative 9. So our 3 goes into our x, and our negative 9 goes into our y. A is the length from the center to the vertex. That's the distance right here of 9. So we can plug that in. 9 squared is 81. Okay, that's got to go into our y term. And then our b squared term has got to go under our x. So we need to find out what b is. We know a is 9. We're looking for b. And then c is given away in our focus point. Since our focus points are c units away from our center, then our c value is root 145. So to find our b value, we can do Pythagorean theorem. So 9 squared plus b squared equals c squared. So then when we square that, we get 145. So 145 is 81 plus b squared. Take away 81 from both sides, and we get 64. B squared is 64, then b is 8. Okay, so that gives us our a, b, and c values. We just need b squared, so we put that 64 underneath our x term, and we have our equation.